Welcome to discussion 32. In today's discussion, we'll focus on section 6.1 on areas between curves. In this video specifically, we will do an example involving finding the area of a triangle. Okay, so this is problem number 1 from worksheet 15, which says consider the triangular region that connects the points 0, 0, 1, 1, and 1, 2. Okay, so I want to have you first try parts A, B, and C of this question. So give yourself 5 total minutes to try these. Pause the video in 4, 3, 2, 1, pause it and try this question for about 5 total minutes. All right, so hopefully you did that. Hopefully you paused it and tried it for about 5 minutes. Let's talk about it now. So part A says to calculate the area using geometry. So let's draw a picture. So let's draw our axes. Okay, and the points, don't go that far away from the origin. So I'm going to put my tick marks pretty spaced out. So I'll go 1 and 2 in the x direction, and then 1, 2 in the y direction. And our points are at 0, 0. There's one at 1, 1, and there's one at 1, 2. Okay, and it says calculate the area of the region, this triangular region. So let's connect these with straight lines to make our triangle. Okay, so it's talking about the area of this triangle. And in part A, we want to do that just using geometry. Okay, so this is an obtuse triangle. It's a triangle where one of the angles, this angle over here, is bigger than 90 degrees. So we have to remember, how do we find the area? First off, of a triangle, well, it's 1/2 base times height. But more specifically now, how do we get the area when our triangle is obtuse like this? So it's 1/2, and I got to think about what my base and my height is. And for this triangle, it's going to be simplest if we think about this length as our base, because we know what that length is without any extra work. That is just 1 unit. And if we do think of that as our base, the way we get the height, because the height is measured as like sort of the perpendicular distance from the opposite vertex, which is here, to that side, the way I draw a perpendicular is I have to extend this side and then drop a perpendicular to that extended side. And how long that perpendicular is going to be the height. And from the picture, I can clearly see that this height is going to be 1. So my height is 1. The base is 1. So my area is just 1/2. Okay, so that is how we get the area just using geometry. Part B says find the area of the triangle using a dx integral. So using a dx integral. So recall our formula for this. The area was an integral from a to b, and then you take the top function minus the bottom function. So we would call this y top minus y bottom. So we would write the equations of our curves as y equals something. So the something would be a formula in terms of x. So this y top would be something in terms of x. Y bottom would be something in terms of x. So that'll give us a dx integral. Okay, so we could get the equations of these lines pretty quickly because I could see the y-intercept of both of them is 0. So if I were to write them in the form y equals mx plus b, for both of them, I can see that b equals 0. And for this steeper line, the slope is 2. So its equation is y equals 2x. For the less steep line, its slope is just 1. So its equation is just going to be y equals x. All right, so if I plug into this formula, a is sort of the smallest x gets on this region, which is 0. And b is the biggest x gets, which is 1. Okay, and then for the top function and the bottom function, for this picture, I don't think it's too tricky. But if I was ever unsure, I could draw some vertical lines. And if I do that, the function that hits at the top, that's my top function, which is 2x. The function that hits at the bottom, that's my bottom function, which is y equals x. So if I were to do that anywhere along this region, the bottom function is y equals x. The top function is y equals 2x. Alrighty, so if I plug in for y top is 2x. I'm plugging in what y equals. That's why it's called y top. And for y bottom, I'm plugging in what y equals, which is x. All right, dx. So I can simplify this. I get the integral from 0 to 1 of x dx that antiderivative is x squared over 2. Got to plug in the 1 and 0. If I plug in the 1, we'll get a half. If I plug in 0, we'll get 0. So a half minus 0 is just a half. So we get the same thing for our area using calculus. Okay, so that's good. All right, part C of the question now says, now find the area using dy. So now find this area using dy. Okay, so I'm going to just redraw my picture very quickly. I'm going to copy it here. Okay, so we have our axes. I'll say this is 1 unit, this is 1 unit, 2 units, and we have points here, here, and here, making a triangle. So these points making a triangle. Okay, and what I need to do now is recall that my formula as a dy integral is it goes from c to d, and I need to know x sub right. So I need to know the right function, and I'll have the x isolated in the equation, minus x subscript left. And then this is going to be a dy integral. So for each of these curves, let's get the equation as x equals something. So for y equals x, I could just write that one as x equals y. The x is already isolated. For y equals 2x, I'd have to divide the 2 to get x equals y over 2 for this steeper line. And for this vertical line, well, the vertical line is just at x equals 1. So now I got to think about what's my right function, what's my left function. And the way I do this is I draw horizontal lines. So if I draw the horizontal line somewhere here, the right function is x equals y. The left function is x equals y over 2. But if I draw the horizontal line somewhere up here, the right function is x equals 1, and the left function is x equals y over 2. So it switches at the y value 1. So the right function here changes at y equals 1. So because of that, so we must split this into 2 integrals. So doing that, our first integral, these need to be y values. The smallest y value down here is 0. And we'll go until we reach the y value 1. And the right function there was just x equals y. So I plug in what x equals, which is y. And then minus the left function. So I plug in what the x is, which is y over 2, dy. And then for the next integral, I get plus. This one starts at the y value 1, and it goes up until the y value 2. Okay, and the right function is x equals 1, so I plug in 1, minus the left function is y over 2, and we have dy. So now we evaluate these. So the integral from 0 to 1, y minus y over 2 is just y over 2, dy plus, we have this integral from 1 to 2 of, you know what, let me do it like this. Y minus y over 2, that is just y over 2. Now let's do the antiderivative. This is going to be 1/4 y squared. Got to plug in the 0 and the 1. Plus the next antiderivative will be y minus 1/4 y squared. And then I got to plug in the 1 and the 2. So if we do that, if I plug in 1 into this, I'll get 1/4. Minus if I plug in 0, I'll get 0. Plus, if I plug in 2 into this, we'll get 2 minus 1. And then I have to do minus what I get when I plug in 1 into this, which will be 1 minus 1/4. And if we simplify this, we end up getting 1/4, and then this thing in this parentheses becomes 1, and then we get minus 1 minus 1/4 is 3/4. So we'll get 1 minus 2 over 4, which is 1/2. So we get the same answer using a dy integral. Just the dy integral was tougher because I had to split up my region into 2 pieces.